Hello there. Today we're going to talk about time series platforms. Is that right, Tor-Inge?
That's right. So we're going to be talking about building your own time series stack, which might be an odd choice for a company who makes a living out of building a time series stack for you. But there's a reason for it. We sometimes encounter customers who've built internal time series stacks. So we'll cover a bit about kind of how those relate to Clarify.
Yeah, and we also get a lot of questions about why can't we just use the TIG stack or use databases that are meant for time series storage already?
Yeah.
So we just want to address some of those questions and the things that we've seen during the creation of Clarify.
There's basically three pieces. So first, we're going to take a look at, you already mentioned the TIG stack. Then we'll talk a bit about real-world cases. So the things that will make your neat architecture expand into some kind of wilderness.
Ugly beast.
Yeah.
Yeah.
Hopefully after this, you'll have the tools to make it not so ugly. And then at the end, we'll wrap it up talking a bit about the generic things about managing your project and how to be successful. Without further ado, let's just kick it off with the basic stack.
Yeah. And for this, we're going to use the TIG stack as an example. There are many different out there. So TIG stack is Telegraph, Influx, and Grafana. Three great tools. There are other ones out there. You can use Power Automate and Power BI and some SQL Server. So depends on the architecture you're looking for. But we'll look at the TIG stack for now.
Yeah. And as you mentioned up front, there's three components.
So it's the data acquisition.
Yeah. So just to give some context here, when you're starting this out, you have some kind of machinery. You might have PLCs, database, external system. When we use the data acquisition, we just mean getting data out of those systems, right? And that has to be, there's some kind of box or component or software that needs to do that. And in this example, we're gonna be sending it to a database that you already mentioned. So we're just gonna actually write acquisition over here. And then storage. And then the final bit is actually using this data for something. And that's when we're talking about storage here, it's important to note that storage in itself is not really the goal of a time series stack. Picking a storage layer, you can't just think about, is it safe? Can we reliably keep it here? How much data can we store? We also need to think about, well, how will we get it out? And how easy or hard is that going to be?
Yeah.
So
you'll not have the people working in a factory or out in the field doing SQL queries. So you need to have some way to access the data in a human-friendly way.
Yeah, and in this case, so I'm going to just I'll write visualization, but in reality, it can also be analytics. It can be various like data science cases. It can be a lot of different things. But in our stack, we're going to go with Telegraph for
the acquisition part,
Influx for storage, and Grafana. And you can now probably guess where TIG comes from. So it's Telegraph, Influx, and Grafana. And the reason you'd want to pick a known stack or a stack at all is because these things work together. So you'll not end up having to write or find a lot of glue code between them. The other part is, if you go with something that's known, you'll get a lot more help than if you architect your own entirely unique
you'll
solution.
find a Docker Compose setup that will spin up this for you in 5 minutes.
Exactly. So not a bad place to start. Picking the software or the components in your stack is one bit. The other part is about picking how you want to run it. So if you've ever done a 5-minute tutorial on setting up either this specifically or any kind of new tech, they're written to be really easy to get going with. And that can be kind of deceiving, because spinning up a TIG stack in a Docker running on your computer, it's going to be very fast. But moving that into something that looks like a production environment, you might want to have backups for your database. You want to be notified if the database goes down or if queries are slow. Once you have it up and running, it's all fine. It just runs, right? But in the beginning, when you're starting out on it, you have to learn all of these things in order to put together something that's reliable and safe to operate. And that's a good reason to, when you're doing this, to think about not just getting it up, but maintaining it over time. And for the data acquisition bit, there are some tools that's come pre-packaged, others software you install. kind of think about what do you want to run. And also, seen a lot of times with this, it's important to think about deployment. If you're going to be logging data from 1,000 similar setups, if you change the setup on one of them, do you want it to change across all? Do you hand do that? How
It's
do you
kind of a fleet management tool
Yeah.
for deploying this. Yeah, it's
Exactly.
really important to think of.
And then on the storage side, if you're running Influx, you could use their managed solution. So then you don't have to think about if the disk space is running out or how the server is actually managed, like how the cluster looks underneath. You can click buttons and scale things up and down as you need. What the right choice is really depends on your case, but also on your organization. Because it's so easy to set up. It's easy to think that it's going to be easy to operate as well. And for a lot of times it is, right?
Yeah, I have this running
Yeah.
at my home
Yeah.
for the home automation system, but I wouldn't put it into production at my factory.
No, right. If your instance goes down on a Friday, that's kind of annoying.
That's my weekend gone.
Yeah, right.
Yeah.
But if the company's goes down on a Friday, that's going to create all kinds of problems for other people. So thinking about the technology to choose, but also thinking about the deployment and do we really want to run these things? Like, are we the best people to run it? So let's move into the next bit where we talk about why are we even doing this? So as an engineer myself, Bernt as well,
Yeah.
it's easy to get so involved in the technicalities of it. We have this awesome stack. It's running so well. It's never going down. Latencies are really low. Everything's looking great, right? But we're not doing it for low latency and awesome databases. We're doing, why did we want the time series stack to begin with? Well,
It's usually our CEO or someone that has some KPIs they want to monitor to improve the process. They want to understand more about how things are working. And so the data collection part has it's a goal to understand and improve.
yeah.
And to be able to do that, you need to give access to data to the people that can do those improvements and start that thought process.
Once you start doing it, at least what we've seen is organizations that start working with it, they become creative. They want new things. They see new ideas. And one thing that commonly pops up, a bit surprising to me now, but been proven out through usage numbers in Clarify, is that people want mobile access.
Now more than ever, they have access to data, and they ask the question, why shouldn't I have access to all my company data or production data on the phone as well?
Yeah, I think it's just a base expectation today. You'd be pissed if you had to run to your computer to check your email or answer messages, or we're used to having access to all of that stuff. And I think in production setting, it makes a ton of sense for field workers, for example. Being able, when you're out in the field, to quickly add a note or check a temperature. So let's say you run the TIG stack again. I'm going to keep mentioning TIG stack until you're sick of the word. You're running Grafana, and Grafana doesn't have a mobile application, but it's a web page. And with some care in designing your dashboards, you can have them shown on your phone. So far, so good. No problem at all, right? Every time we do this for ourselves, we know what we've done and we have an internal picture of what it is. We understand it's a web app and it has its limitations. But then your boss comes and he's seeing that you have this neat icon on your phone because you've made it a shortcut, and you press it and up comes company data, and he wants it as well. No problem. Open his browser, log him in. Maybe you add it as a shortcut. He sees the company logo on his phone. He's very happy and excited, and he asks, have we created a mobile app?
I would say yes.
Yeah, right.
Yeah.
Yeah, it's we want to say yes.
Yeah,
we like
of course.
saying yes. And that's sometimes good. In this case, I'd argue it's not, because it might look and feel like a mobile application. And for what it is, it's awesome. If that's what you're solving, that's fine. And if you manage expectations with your boss, which is what I'm about to talk about, it's managing expectations. If you tell him what it is, it'll be a lot easier for you. But let's say you go ahead and you say yes because you want to be positive. Why tell the boss no when you can say yes? He's super happy. It's a mobile application. Then your boss comes to you a few weeks later. He's had an idea. He's been off to his cabin. He says, Bernt, I had this great idea. Why didn't you think of it? We should have push notifications. Right? When something happens in this app, I want a push notification on my phone. I've seen it. Every app does it. How hard can it be? What you're building and what the people around you think it can do doesn't align. So their ideas and projects for things they want to do with it won't align with what we actually can do.
But putting some hours in, you could be able to create something like push notifications, like doing pager duty with SMS notifications, and
yeah, you can solve it. So let's do two things. One, look at your options. You could say no to your boss. We can't have push notifications, and then you have to explain the difference between a web app and a mobile application, and you tricked your boss 6 weeks ago, and it's not looking good for you. Or you could say, yes, we can. It's going to take me 8 weeks to build, right? And your boss is going to be horrified. It took 6 weeks to get here. Why is it taking 8 to put in push notifications? Should be simple. And that's because you didn't think it through going in, right? There's nothing here to work with. So you have to put in now all the bits of architecture that you're missing in order to do push notification. Let's just look at what does that mean, right? What do we need to do push notification? So if we start off with the TIG stack, we're going to just leave Telegraph and Influx in place. They will work just as they did. And all we have to kind of work with now is Grafana. So we have Grafana here. We have created some cool dashboards. There's some KPIs and stuff. Your boss is happy. You put it on his phone. It's a web application. And now all we have to do is wrap that web application into an app. So we're just going to build an app around it. It does nothing else than run this.
Yeah, there
thing.
are a lot of frameworks to do that, both for iOS and Android. So give me a few weeks and I can wrap that app for you.
So we have in the cloud the database. We have Telegraph writing data to it. We have the dashboard reading out from it. We are running this stuff on our phones. We wrapped it in a framework. And now we have some deployment things to think about. How do we get this to people's phones?
Yeah, can I find it in the App Store?
Yeah, can you find it in the App Store? And that's a rabbit hole I'm not even going to cover right now because it's so deep. The first issue is what things are going to trigger push notifications. There might not be a good way to have Grafana trigger push notifications for the things that your boss wants. So let's just very basically assume that we put up some kind of service on the side here that we run that also connects to the database, right? This is our stuff. We've written some stuff, our own code. Now you're going to need to actually have the push server bit. And that's going to need you integrating with Apple. So Apple, something called APNS, and then Google, if you want push notification for both. So we're going to need a bit of code running on some machine, working with our Influx database, running some kind of logic to determine when to send push notifications and to who. We need the app, the stuff that goes around it, App Store approval or testing scheme, some way of getting it in people's hands. And then we need the application to contact our service to register so that we know that, okay, Bernt logged in and here's the ID of his phone so we can send push notifications to Bernt so it goes to the right phone. That's kind of a basic premise. So we'll need some kind of API in this stuff.
So me as an automation engineer, I had a good idea. I spun up the TIG stack and now I need to know mobile development. I need to know APIs. I need to know Google and I need to know Apple.
Yeah, that's fun. Some documentation for you to read.
Definitely.
It's not impossible. It's just a bit of work. And what's the point here is that now we have some more stuff to manage. And all of this stuff, it's the initial effort to understand what it is. How do we set it up? How do the app communicate securely with our server so we don't leak usernames and passwords or push notification tokens, whatever. All that stuff we have to learn. And then after we've learned it and put it in place, we have to remember it because now we have to manage this somehow.
Yeah, that was my next question. This is good for prototype, but what happens when we want to run this for year after year, updates to iOS, updates to Android?
Yeah, I don't really have a good answer to what happens because the point is that it escalates, right? Which is fine if you're fine with it. But you need to understand the kind of the fallout of all the choices we're making, that everything we put in, we have to manage later on, right? So you've set this up, you have push notification, and you have a mobile app that wraps it, and that's all good, boss is happy. And the next progression, which we've seen so many times, is once you have this up, it's very easy to want to, or even have begun to think of this all as a platform.
So when the boss wants to give access to this data to a third party, a consultancy company, or anyone, he thinks that that's just giving out a username and a password, isn't it?
Yeah, and that's where we can start to think about what does this look like at scale. Because, as I said, if you want to give third-party access to the UI, that you're probably able to set that up somehow in Grafana, and you can make groups and teams, and that's fine. But the third party might want to build something on top of it. Or you have internal teams who want to make visualizations that run on data on this or that are...
Yeah, we need access to the raw data.
So let's just look at it very basic. We have data acquisition, we have data storage, and we have our visualization on top here. And those things all plug neatly together. That was kind of the argument for choosing it. It's a TIG stack. It all works neatly with each other. But now we're wanting to run other applications. We want to connect it to Power BI. Someone has some kind of custom 3D visualization. Somewhere in the
Digital
distant
twin?
Yes. Yeah, I was just about to say. Digital twin, always a thing. There's so many things here that we want to connect. Some of them are internal, and we know the people who connect to them. Some of them are external. We don't know the people who connect to them. And when you have more than one of these things and it starts adding up, you need to put in the things around that we didn't have to do initially, like throttling. No service can request data here at some infinite speed because it will prevent everyone else from requesting data. We need ways of handling access for each of these. They have to have some kind of authentication, either API keys or OAuth tokens.
Can't you just give them direct access to the database?
Yeah, that's a fair question. For one or two internal teams, you probably could, but at scale, you're gonna need to start doing stuff. You'll need caching for things. You'll need your own management layer. And so we have our small API on top here. We have a connection out to APNS and Google for push notifications, and then we put in a basic API here, and then we put in some access control system on the side, and that is requested by the clients, but it runs through the API. And then we have a caching layer, and there's some stuff on the side to manage rate limiting. And then we need error reporting for the API so we understand how people are using it.
And where is this all running? Is it the local server in the office, or is it in the cloud? Or
yeah, again, C.1. What choices did you make, right? If you deploy this to one of the cloud services, now your setup is more complex. You're starting to think about security groups. How
you can use Kubernetes, can't you?
Yeah, you can use Kubernetes. We can keep expanding this and we can add all kinds of complexities to it. But the main point is your neat package stack.
5 minutes package stack, yeah.
Is now a beast, right? All kinds of components that need to talk together. So that's a good place to move from looking at these cases to looking at the high-level picture. What's the argument we're trying to make here, right? The first part is prototypes are not for production. And getting a prototype up and running is good. That's not a bad thing. We can use prototypes to better understand initial or internal requirements. We can use it to come up with new ideas. We can use it to get to learn the technology and see what fits and what doesn't. But a lot of times people want to think about code and the work that goes into it as an asset. Code is a liability, not an asset. And it's because every line of code that we write, we have to support and maintain. We have to get away from the idea that the code that we generate in itself has value. What has value is us understanding why the new production line has a 5% higher rate of defects for the stuff that we produce, right? Understanding that we have that problem, being able to dig into it has value. The code that lets us do that doesn't really.
No, if you can solve it with pen and paper, and that solves the problem, that might be the best solution.
By all means, go ahead, right? And it's important to shift that thought, because once your prototype is done and you've spent weeks on it, right? You even wrapped the mobile applications. Now you're really committed to it. If you think of it as an asset, the natural progression is we built the prototype, we spent all this time doing it, boss is happy, so we want to keep it. We want to Jenga tower our way into the sky, right?
Into the time series platform.
Yeah. And if we do that, we completely miss what I think is the biggest opportunity with a prototype, which is to learn stuff that we can use in actually making the solution. Maybe we chose initially that we're going to run Influx in a Docker container inside of Kubernetes, right? And then later on down the road, we figured out that's actually not a good idea for us because we don't have the capacity to manage server faults at 5 p.m. on a Friday. And then we might want to do something else. We might run their cloud managed solution. We might have written our own push notification service and then later realized that, oh no, there's a third party that actually does that really well that we could integrate with instead. So we'd save like half the code. And that's better. It's not because you have half the code, you now have like less value. That's way better. Less code is awesome. If you're solving the business problem by combining things that work together, that's awesome. That's a good thing. So don't mistake your prototype for an asset. It's a learning opportunity. And if you throw all of it away and restart it, it's not wasted work. It was just planning. It's just understanding the problem. Next up, you talked about, you mentioned this about like hire a database engineer. I think that's a thing that's really important when we think about if we should build something ourselves, and if so, which part do we build, how do we run it? Being honest and being realistic about the operational capabilities of your organization. If you're the only one who can program, do you really want to have 3 different languages on 2 different platforms? Like, can you do that, right?
And if you're also the guy maintaining all the automation systems and all, like the factory in general, then throwing on the added complexity of running software on scale in the cloud, it becomes a lot of stuff to know and maintain. So
and you need to be realistic about them. We've seen so many times where there's a single engineer, or maybe 2, who they become the most popular people in the entire company. Like everyone comes to them, right? Because everyone wants to extend the functionality of this thing, and you'll be so bogged down in just running it that you won't be able to innovate any new stuff in it. Like forget about adding new stuff. You're just trying to keep it floating, and if you manage that properly in the beginning, you can make you can make realistic decisions so that we can, for example, say that if we are doing this, we need to commit to it. We need to put the right amount of people into the project. So we're going to need to hire these people. And that's a way better argument and way better time to make it when you're planning, should we do it or not, than later when you have 3 different departments relying on it, right?
Yeah. And also managing that expectation that like we're now building a prototype to learn, not to run. Like do that from the start, it'll save you a lot of headache.
Yeah, for sure. That's a good segue into the third bit, which is just expectation management. There's 2 highlights. The one is the one you mentioned, like what is it that we're building? So you said earlier about when we talked about the mobile application, right? It's important to lay out what's in scope for this and what's out of scope. What are we going to do? And then when you do it, to be clear about what is it, what can we do and what can't we do with the solution we've chosen. So feature-wise and just not kind of overselling what you're building, but being realistic about it means that the ideas and the concepts that will emerge inside of your organization will fit with what you actually built, instead of having a lot of great ideas that you can't possibly do.
Yep.
And the other part is the infamous, I get asked whenever someone in our team makes something that looks cool and shows it to our CEO, inevitably he will always ask the question, how long until this is in production?
Because it's already there, like it's working, you see it. Can we just throw it in there?
Exactly.
And like, so managing that, the difference between a prototype and a production-ready set of code.
I won't go so far to say that you shouldn't show it to your boss. I think it's always good to share, but it's also important to it's natural for us to want to be positive and say like, yes, this is like, but done in zero time to set up. It's gonna be running, right? And the problem with it is that initially, we have some business outcome that we want to do. We want to learn more about the new production line. We want to debug this issue. We want our remote teams to have more easy access to data. We have those requirements, right? And it's important for us to have them so we can come up with the right architecture. It's also important for us to have them so that we can look at, okay, should we build something at all?
Yeah, you have the requirements. You could create a prototype to see that you find a solution, and then you need to take the decision on how to take this into production.
Yeah.
Should you hire a team? Should you get the necessary resources to do this internally? Or should you go out and buy hosted solutions or solutions from other companies? And there you have a lot of different solutions available. You could buy a hosted version of Influx. You can buy a hosted version of Grafana. Clarify is available as a hosted solution. And all of these technologies still play together.
They do. And that's I think that's a good thing to end this entire bit on.
So to wrap this up, manage expectations, do prototyping, test out all the cool technology there, the TIG stack and all the great companies, but just know that it's a prototype and plan for how to run this in production.
Yeah, and if you want to look at the specifics on how to put this up and get started with it, we'll include some links so you can find some 5-minute tutorials, but remember, 5-minute tutorials will not cover all the complexities. So
and please reach out to us if you have any questions and comments, and we love getting feedback from our users and people watching.